Hello everybody. In this video we are going to look at the process of how to do a titration. In subsequent videos we are going to look at how do we read some of this equipment as well as practice. So a burette is what is going to hold one of the liquids that you're using in your titration. Typically you're holding the liquid that you know the concentration of. The stand holds that burette. The tap releases whatever liquid is in your burette. What they've labeled here as the conical flask, we actually call an Erlenmeyer flask. And then under the Erlenmeyer flask, we either have a white tile or a ring stand that we put a piece of white paper on, because that's going to allow us to be able to see the color change much more easily. And as I said, we're going to go more in depth with how exactly do we need to read a burette, but you always read glassware at the bottom of the meniscus. So like I said, we're going to watch part of this video together. I'm going to narrate it for you, and then we will learn a little bit more in detail. So what you're going to see first is the scientist is measuring an amount, 25 milliliters of hydrochloric acid, that they don't know the concentration of, into that Erlenmeyer flask. We always need to know the concentration of both things because we're going to be using that MAVA equals MBVB formula that you learned in the last lesson. So we know the volume of acid, but we don't know the molarity. So then we have to add an indicator, something that's going to tell us when are we done with this titration. The second thing that we need to have is we need to have a known concentration of the other liquid. So we did not know the concentration of our acid, so we need to know the concentration of our base. So we know the MB, and we are going to use the burette to figure out how much base was added. So the burette in this video was filled to the 0 mark, 0.00. That has to be recorded initially so we can measure at the end how much has been added to this flask. Now you're going to notice in that flask that it starts turning pink. That pink is because when base is added, or when the pH increases, the phenolphthalein, which is the indicator, changes color. The more of the base, or NaOH, that is added, the greater the pink, or the longer that pink color is going to stay. We will know when we are done with this titration when the pink color remains in the flask even after it has been swirled. So I'm going to skip ahead a little bit. This can be a pretty tedious task. I'm waiting for it to change, and you don't want to add too much of what is in the burette because you don't want it to get too pink. So at this point, the scientist is adding that NaOH, or the base, drop by drop and swirling it after each time they're adding the drops, because we don't want to add too much base because that will change our calculation that we have to do. So now they've reached the end point because that pink color stayed. So the next part that the scientist has to do is they have to look at the burette to figure out how much was actually used to neutralize the acid. So they're giving us a picture of the volume on this burette. Burettes are different than most of the glassware that we have read all year. We'll go more in detail, but brief description. We see that that meniscus is right between the 25 and the 26. Now normally we read bottom to top. With the burette, because the numbers increase from top to bottom, we actually read this from the top to the bottom. So instead of being 26 point something, this is 25.4, which is what they've recorded. But when you're reading a burette, when you're reading any glassware, you actually want to record one place past what you can read on the instrument. So I would record this as 25.40. Like I said, more in depth in the next video, because in your lab scenario, you are going to have to read burettes to complete your calculations.